In this video, I want to have a look at motion graphs. So there's a few things we need to clarify before we start having a look at the graphs. So the first thing is that if we have acceleration and velocity in the same direction, so either they're both positive or they're both negative, so they have the same sign, then that means that our particle is speeding up at that particular point. If the signs are different, so between acceleration and velocity, one's positive and one's negative, that means that our particle is slowing down. If the particle is traveling at a constant velocity, then that means that there is no acceleration. So we want to have a look in this video at what those points look like when we're looking at a graph. So we're now starting to have a look and comparing the physical applications of our calculus with their geometric representations. So we know that velocity is the first derivative, and geometrically, the first derivative is talking about the gradient. So when we look at a time displacement graph, then our velocity is relating to our gradient, and our acceleration, which is our second derivative, is relating to the concavity of that graph. So we're going to have a look at an example, and we've got this time displacement graph drawn here. Now sometimes you'll be given a question that just asks you to describe the motion of the particle. To help us out a little bit with this example, I've put some specific points on there, and we're going to go through and explain what's happening at every single one of those points. So the first point here with point A, we can see that the gradient is positive and the concavity is positive. So that means that our velocity is positive and our acceleration is positive, which means that our particle is speeding up. And we're going to talk about left and right in this problem. So if our graph is going up, then it's moving right, and if it's moving down, then it's moving left. So at A, our particle is moving to the right and it's speeding up. At point B, our gradient is still positive, but our concavity, point B there, that's a point of inflection, so our concavity is 0. So that means our velocity is positive, which means it's moving to the right, but our concavity, so our acceleration, is 0. So that means it's still moving to the right, but it was speeding up, and you can tell that because the gradient's getting steeper, and now it's stopped speeding up just for a second, and as we move on, it's going to start slowing down again. So that brings us to point C. It's still moving to the right because we've still got a positive gradient, which means our velocity is positive. So it's still moving to the right, but now because it's concave down, that means acceleration's negative. So we've got a positive velocity and a negative acceleration. That means it's slowing down. So at point C, it's moving to the right, but it's slowing down. At point D here, that's when our particle comes to rest. So this is a stationary point. Our velocity is 0. So our particle has come to rest. It is at rest. At point E, our gradient is now negative, which means our velocity is negative. So that means that our particle is now moving to the left instead of to the right. And our concavity here is negative as well. So our velocity is negative and our concavity is negative. Sorry, acceleration is negative. Because they're both negative, that means it's moving to the left and it's speeding up. And the last point here, point F, our gradient is still negative, our concavity is still negative. So it's still moving to the left and speeding up. But the important point about this is because it's come back to this line, that means that our particle is passing through the origin at that point F. So to summarize all of that, I've got each of the points here. I've got their velocity and acceleration, and then a translation of what that means and how we can describe what's happening at each point there. Now, one thing that's really important to double check anytime you get a question like this is check whether it is a displacement time graph or if you're given a velocity time or acceleration time graph, because it'll completely change what you're analysing if you're given a graph of your first or your second derivative. Right, so that's having a look at motion graphs.